I want to talk to you a little bit more about one of these partner applications in Augury that we can get value from immediately. But before we do, can I just invite you to join me around the lake? So you can see we have the tree here. You're sitting resting from this long day. Anybody like to fish? Any fishermen? Yeah, a few. Anybody like to eat fish? Okay, there should be more hands for eating fish. I want to introduce you to a day at the lake, right? And if you're going on the lake and you're a fisherman, it's your job to identify the right mix of bait and the right reel and rod in order to find where the fish are. Now, before you leave, this is not a conversation about fishing, but I did want to introduce you to a tool called a fish finder, right? If you've used this before, have you used this, sir? As a fisherman? No, he's a real fisherman, so he doesn't need a fish finder. If you're not familiar, this tool will help you identify where in the lake fish are. And then so you can cast appropriately. It doesn't matter what kind of bait you have if you're not casting where there are fish, right? So this tool is a device for fishermen to help them find where the fish are so that they can get what they need. Now, the real interest here is not something that happens on the lake, but something that happens on shore, right? In a processing plant or some other facility. People don't need fish finders, but they need machine health. And Augury is here to offer machine health and machine health that works. So this solution doesn't help people know where the machines are, but it does give them the insight they need in order to manage them most effectively, to give them a sense of the machine's health, the severity, where they need to spend their attention so that they can cast in the right place and catch the right kind of problems from the get-go. So I'll tell you a little bit more about Augury's solution, but probably the best way to do that is to just share with you the value that we've been able to bring with Schneider Electric. I'm going to ask for a little help on the slides to advance the slides, but I'll introduce you to an OEM of ours called Nordic Clean Pumps, and they make, of all things, a solution that helps to grow fish. Did you know that fish could be grown outside of the sea? In Iceland, they can. So this is a facility that Nordic Clean Pumps has produced. You can see it's a series of tanks. They pool water from the sea. The energy is quite efficient in Iceland, and they're able to grow salmon, a redfish. Now, don't worry. I came from the US. We don't have really good salmon, but we do have Swedish fish. On your way out, you're welcome to grab your very own redfish while you're here if you need a little caffeine or sugar pick-me-up. But it was here that Nordic Clean Pumps came to us and said, we are very good, a new OEM, but we have 10 years of experience, each of us in delivering this solution and designing these kinds of facilities. But we're having trouble giving value to our customers once we leave. So we can design a facility, we can build the facility, but now we need to be able to give our end users, our customers, the ability to keep these machines running. So what happens here is they have a series of pumps, of course, that move water, and then they have a proprietary system that puts oxygen in the water to make it suitable for aquatic growth, right? So if you lose the oxygen or you lose the pump, you lose the entire tank of fish. So it's a pretty critical application. So let's zoom a little bit further and I'll show you more about the solution that we were able to deploy. So Augury is a machine health solution. We connect a sensor like this onto machines, fixed rotating equipment, and it's there that we can get all the data that we need to get actionable insights. The sensor itself includes triaxial vibration, it includes temperature, electromagnetic flux. We're taking this and the 350 million machine hours we've gotten of data, and then we're able to interpret that with some AI and visualize it in a platform for our end users then to take action on. In this specific case, you can see the pump at the top that we were connected to. Now this pump is located in an underground bunker underneath these facilities, so it's a pretty challenging environment to get data anyway, and it's a pretty tough environment. You saw how big the spread of the facility was in order to do even just route-based maintenance. So in this case, the sensors were blue that we've attached here because blue matches better with the ocean, and the machine is initially connected. Now, if you're familiar with vibration analysis, this usually takes months and months and months, right? You're trying to get a sense of how the machine performs. You're capturing that image and validating it over machine health later and later and later. This machine was baselined in 30 days, we were able to bring it into an acceptable status because we leveraged the power of all of this other similar like and kind data. Usually for even more severe machines, we prioritize their baseline status to come out in a matter of days or weeks. But in this case, the machine comes in acceptable. Now, where I sit, my interest is to see machines go into alarm because that means we found something for somebody to fix and we've added value for them. In this case, it came back unacceptable, but this is a value in and of itself because it means that the maintenance teams, the OEM, doesn't need to spend time identifying issues on this particular pump. It's a brand new pump, it's a brand new facility. We ought not to spend our time and attention here, but we can reprioritize it to something that's more severe where our attention would need to be required. So comes in acceptable just a few days after it was initially connected. We're getting the data. Now, this is where the magic happens. If this is your facility, this is where you're frustrated. From where I sit, this is where we've generated value for you, right? So the machine is now moved into an alarm state. Now, before you think this is a red light, green light, orange light kind of a situation here, this is the data that we're getting. So remember, we've got the sensor on the machine. We're getting the data. It's being interpreted. And this is the kind of data that we're getting. We're getting feature data, RMS data, and you can see that we've identified a rapid cliff, just an anomaly in the data. We're getting a longer cliff, a really rapid cliff here. We're seeing some information down here that some of our users can make sense of. Many of you smart people here can look at data like this and make really good predictions as to what's going on and how you need to fix it. You have some folks that work in your facilities or that you equip that this is too much for them. They need to turn wrenches and fix things and fix them quickly. And so we translate these insights into more actionable insights, like easy to read text that guides the user in exactly the thing that they need to do. And we identify the specific faults and the severity of each specific fault. Of course, it's all backed by evidence, and we reveal the evidence to the parties that need them. But the idea is you have really nice, actionable, easy insights. So the machine was connected. At first is in a good shape, in good condition. Now we've gotten enough data to validate that there is a change that needs to be acted upon and acted upon immediately. So our services team reviewed the data with the human vibration analyst. We have a software platform where the communication lives that our end users adopt. And so now we guide the user into identifying what the next step is. I'm going to ask for help one more time on moving that forward. So after it moves into alarm, maybe operator error, then we guide the user to identify what they've done about it. So you may know this as much as we do, that insights are great, but the measure of how great they are is how actioned they are, right? So if I tell you something and you don't do anything about it, it tells me that my insights aren't that significant, right? If you learn something at the conference and you go and implement it into your company, that means you got good insight, right? At Augury, we measure our response rate to our insights at 90%. So that means 90% of the time when we say something is wrong, then our end user is doing something about it. And so the end user logs this event to say, we performed the repair as you indicated, and then we're looking at the data on the backside to validate that what they did actually remedied the issue. So as you know, whenever you introduce a change, even a good change, you can also introduce a good fault. So we see this process through all the way to the end. They indicate that they were introducing a repair. The repair was successful, and then it moves again to the acceptable state. So this process, these are real timestamps, by the way. So we started in November of last year. We ended in January of this year. The alarm first came out on January 25th. And later the next day, it was resolved. It was 29 hours from the time that the alarm event happened. The customer got the alarm, they responded in a repair, and it came back into a successful repair. You want to know what they did to fix it or what the problem was? They found a screwdriver in the pump. Okay, so this was a big facility. It's under construction. They're sucking in water and fish, water and fish, water and fish. In an open construction site, you don't end with all the things you started with, and so a screwdriver had gotten stuck in the pump and was sucked in. We caught it immediately, and instead of losing the entire pump, a brand new pump, they were able to repair it and bring the tank back to an operating status And the best part of the story is none of the fish died. Now, spoiler alert, they would all die a little bit later because they were being exported for consumption. So if you're keeping track here, this is what success looked like. In one single machine health event, from acceptable to danger, or alarm rather, and then back to a successful state, in a time of 29 hours, there was a 50K savings, meaning the customer told us if we had to overhaul that pump, a brand new pump, it would have cost us a whole lot more than it would have to just do this simple repair in the first place. Okay, that's pretty nice. But over the course of 5 months, we've only been deployed 5 months. We've been able to generate for them, these are their numbers that they've generated to us, 5 times return on their initial investment in only 5 months' time. So when we talk about AI and big data and compiling data sources, there's a place for that. But there's also a place for ready-made AI where you can install a sensor on a machine that's running and you get 5 times return on the investment in 5 months. And that's what we were able to generate for Nordic Clean Pumps as they generating that benefit and that savings to their end customer there in Iceland. So thank you for the time today to talk about machine health. But not just any machine health that works for the machines to give you good, actionable insights on the machines themselves, how to fix them, but also gives quality of life to the people who are serving in these critical industries to know exactly what they ought to spend their attention on and what they ought not to. So if you'd like to learn more, you can fish yourself over. We're just behind the wall here. You're welcome to enjoy your own fish finder of Swedish fish if you like. Does anybody know Swedish fish? They market this in the US. We've got a mandalas right here. Yep. So thank you for your product. Thank you for letting us help you make your product. And it's available here for you. So thanks for the time. And thanks for letting us talk about machine health, the machine health that works.